In this video, we're going to be talking about how you find the probability of independent and dependent events. And hopefully you already have some understanding of what it means to be independent or dependent. If you're independent, you kind of stand by yourself. Dependent, it means you what happens depends on something else, something that happened before that. And if you're dependent, you depend on your parents for a place to live or money or food or something like that. Okay, so we have independent and dependent events that happen when we're talking about probability as well, and they affect each other's probability. Okay, so take this example. You have a bag that contains 5 blue, 8 red, and 7 green marbles, and you want to know the probability that you will randomly draw a red marble. All right, so this is just a single event. So if we want to know the probability of red, all we're going to do is figure out how many reds there are. There are 8 out of how many total. All right, so if I add up the 5 blue, the 8 red, and the 7 green, I'm going to get 5 plus 8 is 13 plus 7 is 20 total. So I know the probability of getting red would be 8 out of 20. Right? Can that be simplified? Yes, they're both divisible by 4. So 2 out of 5. All right? Then it says, what's the probability that your second draw will also be a red marble? Right? So we found the probability of red was 2 out of 5. We want to know the probability of red and then red again. Okay? So do you think it's just going to be 2/5 again? Okay? Or is it going to change? All right? So the first time we chose red, it was 8 out of 20. What about the second time? Is it going to be 8 out of 20? Well, that kind of depends. If you took a red out, do you still have 8 left? Nope. Okay. Let's say you took a red out. Do you still have 20 marbles? Nope. Okay, what if you took a green out? Okay, would you still have 8 red? Yes. But would you still have 20 marbles? No. All right, so the second draw is something we're going to say is dependent on the first draw. Okay, so the first draw, you just start with what you already have. Okay, you start with what's given. Okay, it's the independent event. Find the probability of that one, no problem. Okay, the dependent event is what comes after. Is that event affected by what happened first? Well, it could be, unless you just put the marble back. If we put the marble back in, do these numbers stay the same? Yes. Okay, so that's what we're going to be looking at in this video. So the information that was left out of the scenario is what you need to answer the question. Okay, did you replace the first marble before drawing the second time? Okay, so we need to know, did they put the marble back before they drew the second one, or did they leave it out? Now, if they don't tell you, then you have to assume it was not put back, okay? But we'll look at that in a minute. All right, so the first time, if they put it back, that's called with replacement. They replaced it. So then the probability of red would be the first time they drew red, probability of red was 8 out of 20. And if they put it back, then the second time they draw red, it's going to be the same thing, 8 out of 20. Okay, they're both going to, the probability doesn't change if you put the marble back. So if I simplify both of those, that's 2/5 for each one, so that would be 4 out of 25. Okay, 4 25ths. Okay, and because we're going to compare these, I'm going to go ahead and change it to a percent, so top and bottom out. It'll go once, and when I subtract, I get 15, bring down another 0, it'll be 6. So this changes to 16%. All right, when I don't put the marble back, that's called without replacement. Okay, I don't put it back, I don't replace it. Then the probability of red the first time was 8 out of 20. But the probability of drawing red the second time is, right? So I go from 8 red to what? If I take out a red, then this is no longer red, this is 7. And this is no longer 20, this is 19. All right, so then this would be, the second time would be 7 out of 19. All right, so then if I go ahead and simplify 8/20ths, because I know that's 2/5, times 7 over 19. I get 14 on top, and then 5 times 19. I need to do that. 45, carry your 4, 5 times 1 is 5, plus 4 is 9, out of 95. So the probability of red then red without replacement is 14/95, or if I change that to a percent, 95 will go into 140 once. And I subtract 95. I'm going to get 13 minus 9 is 4. Bring down to 0. 95 will go into 450 about 4 times. 20, 36, 38. Okay, and this is going to go on, but I'm going to go ahead and leave it there and say, okay, so this is about 14%. Okay, so if you replace the marble, you have a better chance of getting red the second time. If you don't replace the marble, okay, then your percent goes down for getting a red marble the second time. Why do you think that is? Probably, right, because you have less red marbles to choose from if you already took one out. Okay, all right, so let's continue thinking about this. When one event affects the outcome of the other event, the events are dependent. Such as drawing a marble from a bag and not putting it back, then drawing the second marble. Okay, this is what we just talked about. So it affects the outcome of the second time because there are less marbles. Okay, when one event does not affect the outcome of the other event, then the events are independent. They don't affect each other. Okay, this might be rolling a number cube and then flipping a coin. Okay, so rolling a dice and flipping a coin, they don't have anything to do with each other, so they're independent. Okay, flipping a coin is not going to determine how you roll your dice. Okay, drawing a marble from a bag, but putting it back makes it independent. Okay, if you put it back, then it's not going to affect the next marble you drew. Okay, all right. So what you're going to do is be looking at compound events, so more than one thing happening, and then first of all, just deciding, are the events independent or dependent? All right, so determine whether the following are independent or dependent events. If you flip a coin 2 times, so I flip it once, and then I flip it again. Okay, so does the first time I flip it affect how I flip it the second time? Nope, then these are independent. Doesn't change. Okay, selecting a name from a hat, not replacing it, and then selecting a second name. So I pull a name out of a hat, okay, and then I select a second name. Okay, did that change? Like if I don't put it back, are there less names to choose from? Yes, then that makes it dependent. Okay, you spin a 4-colored spinner and then roll a number cube. Okay, is this going to affect that? Nope, they're completely different, so they're independent. Okay, what about selecting the name from a hat, replacing it, and then selecting a second name? Independent or dependent? Okay, so if I take the name out, right, then I have less names, but when I put it back, am I starting with the same number of names? Yes, then that makes it independent. All right, picking 2 cards from a deck without replacing the first card. All right, so I have some playing cards. I take 2 out. Okay, so I take out 1 card, and then I'm going to take out a second card. Okay, if I don't put it back, is that going to affect? Yeah, so if I take out the Ace of Hearts the first time, can I get the Ace of Hearts the second time? Nope. Okay, so this makes it dependent. I have less cards to choose from. All right, look at number 2. 1 letter tile is selected, so I've got 4 letter tiles and a spinner, and the spinner is spun. Are these independent or dependent events? Okay, so does this, what I choose here, going to affect how I spin here? Nope. Right, so then these are independent. It's not going to change. What's the probability that both will be a vowel? Okay, so if I just want to know the probability of a vowel and a vowel, right, then I have to find the probability of getting a vowel from the letter tiles. So what are my vowels? A, E, I, O, U, right? Right, so in the letter tiles, I have 2 vowels out of how many total? 4. I'm going to take 2 out of 4 and multiply it times, what's the probability that the spinner will be a vowel? I have 1 vowel out of 3 total. If I multiply those together, I get 2 out of 12, and then I simplify it, I get 1 out of 6. Okay, so finding the probability of independent events, you just did what we did in the last video where you just multiply them together. What is the probability of a G tile and a C spin? Right, so the probability of G from the tiles is 1 out of 4. Probability of a C spin is 1C out of a total of 3. So 1 out of 12. Okay, and it can't be simplified, so that's my answer. All right, look at number 3. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Izzy selects a piece of fruit to eat at random, and then Ted selects a piece of fruit at random. First, I need to decide, are they independent or dependent events? All right, so Izzy takes out a piece of fruit, eats it. If she eats it, can she put it back? Nope. Okay, and then Ted takes out a piece of fruit. So if Izzy chooses an orange, all right, does Ted have less oranges to choose from? Yes. Okay, so then these are dependent events. All right, so we want to know the probability that 2 apples are chosen. Okay, so the first time, okay, when Izzy selects the apple, her probability of choosing an apple, okay, was 5 out of how many? Well, we have to add these up. So 4 plus 7 plus 5. All right, so this becomes 11 plus 5 is 16. So 5 out of 16. All right, then I want to know the probability that now that Ted chooses an apple. Okay, so Izzy's eaten her apple. So are there still 5 apples? No, now this is changed to 4, right? Okay, and so this is not 16 anymore. 4 plus 7 plus 4 is now 15. So the probability that Ted gets an apple would be 4 out of 15. Okay, and then after I figure out that probability of the individual events, finding the probability of their compound event is still the same. You still just multiply. So 5 times 4, right, is going to be 20. And then 16 times 15 is going to be 30. Let's see, that's 8, 0, 6, 1, 0, 14, 240. Okay, so can that be simplified? Yes, these are both divisible by 20. That's going to give me 1 out of 12. Okay, what's the probability of a banana and then an apple? All right, so if I go back to how I started, right, there are 7 bananas out of a total of, I have 4, 7, and 5. So when I add those up, I got 16. All right, so 7 out of 16. Okay, then when Ted chooses his apple, right, does he have the same things to choose from? No, because Izzy took out a banana, so there are no longer 7 bananas, there are 6 bananas. Okay, and there's not 16 pieces of fruit, there are 15. So the probability that Ted's going to get an apple, number of apples stayed the same, it's still 5, but there's less fruit, 15. All right, so then I solve it by multiplying. 7 times 5 is 35. Okay, 16 times 15 I did earlier. 16 times 15 was 240. Okay, and then I just need to simplify it. All right, and these are both divisible by 5. So that would be 7 over, and if I divide 5 into 240, it'll go, let's see, 4 times. Subtract and get 40. 5 will go into 40 8 times. So 7 out of 40. All right, so independent and dependent events. What you have to decide is, does the first event affect the outcome of the second event? If not, it's independent. If it does, then it's dependent. All right, when you're finding the probability of events, of a compound events, you decide first, does the first event affect the second one? If it doesn't, then just find the probability of both of them and multiply. Okay, this is what we did in an earlier video. Okay, when it is dependent, when you can answer the question with dependent, right, then you're going to have to think through, all right, well, how's that second probability change? The first probability is going to be the same as you've been finding, okay, but the second one is what happened to this situation? How's it changed now that something, now that the first event occurred, okay? Then once you know that probability, you still just multiply and simplify. Okay, see you soon.